Hello. Today I am going to configure load balancing in the MikroTik router OS version 7. The idea here is that we need to load balance the traffic, the connection that is coming from the LAN connection, the host 4, 5, 6, 7, through the 4 ISPs. The problem that we have here is that the MikroTik is not directly connected to the ISPs. So therefore the link will be always up, and if the ISP goes down, the MikroTik will keep sending traffic toward that ISP. To resolve that issue, we are going to configure the recursive route by pinging the public DNS. For the public DNS, I'm going to use like Google and Cloudflare and some. We need 4 public DNS, so you can choose any of your knowledge. So okay, so that's all. So let's begin. Let's connect to the MikroTik WAN box. And first, all the interfaces that they are configured. So I'm going to go directly to the firewall mangle, so we can create mangle rules. Mangle is to mark the packet, so we need to create connection. So in order, let's go back to, yes, we need to first we need to mark traffic, but before we need to accept the traffic that are going from the LAN to these ranges that's connected to the ISP, in case we want to connect to the subnet. We need to accept this range, so do not mark them. And then for the other traffic, we will of course mark the inbound traffic that is coming from the LAN, and also the incoming traffic that is coming from the WAN. Okay, let's go back to the WAN box. First we need to create rules. Mangle pre-routine destination address is the subnet of ISP 101. So, and in interface LAN, and the action is accept. Okay, apply, copy to create the second one. The second one will go to the subnet of ISP2 in interface LAN, and also the action is to accept. Apply the third one, that will go, copy. The third one is the subnet of ISP number 3. The action is accept, apply, and copy. The last one is destination is 104. Okay, and apply. Okay. So yeah, and now we need also to permit the traffic that is coming and going from the local subnet. So the pre-routine destination address list, because I have created the local net. So if you need to create it, so you address list here. So I created local net, which is referring to the local subnet. So also we need to permit the traffic that is coming and going from the same subnet. Local net destination address list is the same local net. Okay, the action is to accept also. Okay. Now we need to mark the traffic that is coming from the ISPs, because even the traffic that is coming from the ISPs, we need them to go out using the same interface. Otherwise, some connection will be dropped. So pre-routine in interface 1, and the action is to mark connection. Let's name it ISP1 connection. Okay, and then apply, copy will mark the traffic coming from the second ISP. We will mark it as ISP2 connection. Okay, apply, copy the third interface. Action is to mark the connection as ISP3, apply, copy, and the last one is ISP104. Action is ISP4, apply, okay, and then okay. So, and now we need to mark the traffic that is coming from the LAN, but to dispatch the to create like 4 connections. So because we have 4 packets, we need to create to mark the packet, to mark the connection, but in the same time we need to dispatch them between the 4 ISPs. So for that we go to the Mangle pre-routing. In interface it is LAN, and advanced it per connection classifier. We are going to use both addresses. We have 4 links, and the first one starts with 0. Okay, the action is also we need to mark connection, and to mark connection as ISP1. Okay, as ISP1. Okay, apply, copy, the LAN also advance. Now it will be the second connection. Action ISP2, apply, copy, advanced to, and action apply and copy. The last one is advanced, is the last link, and action is to mark it as connection 4. Okay, apply, okay, and okay. So yes, and now we are going to those packets, we are going to specify where they are where to go. So we are going to create like routing mark. So for that we are going to add it, and now pre-routing in interface 1 connection mark. If it is marked at ISP1, the action is to go and to mark the routing. Here it's not like the version 6. So in version 6 we can create like a new routing mark from here, but in version 7 it's a bit different. You need to go to the routing table, and from here you need to add a new routing mark. We create the first one via ISP1, okay, apply, copy via ISP2, apply, copy via ISP3, apply, and the last one via ISP4, apply, okay. So we created the full routing mark. So now if you go here you can find them via ISP1. Okay, apply, and no, okay, apply, copy the second one. Okay, one, no, we did mistake. Okay, the first one is one in interface LAN, not 1. Okay, and via ISP1. Okay, apply. Now we did copy, connection 2, and mark it to go via via ISP2. Okay, apply, copy, mark connection, ISP3 connection mark. The action is to go via ISP3, apply, and the last one is ISP4 connection. The action is to go via ISP4, apply. Okay, 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 okay. And now the last one is to mark the output routing, and the output should, if it is connection 1, should be via ISP1, and if it is connection 2, to go via ISP2, etc. So we need to add the output. This time it's the chain is output, and the connection mark is via ISP1. No, ISP1. The action is to mark routing and to go via ISP1, apply, and then copy. If it is ISP mark connection, if it is marked at ISP2 connection, it should go via ISP2 in output, apply, and then copy, and then via ISP3. The connection is connection 3, and apply, and last time is via ISP4. The connection is ISP4, apply. Okay, 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 okay. So yes, I think we finish here. So before we go to the routing, let's go and configure the NAT so we can masquerade the outgoing traffic. Okay, the chain is source NAT out interface 10. We can do it interface by interface, or in my case I group them in one output list. So it's here, I think. Yeah, it's one, and once it will group all the one interfaces. So out interface list 10. The action is to masquerade, apply. Okay, okay. So now we have connection. We still have no connection created yet. Okay, we need now to go to the IP routing, and we are going to create the route. Okay, here, and because we are going to use the public DNS, we need to mention to the MikroTik in case each IP which ISP to use. For example, the first one I will use 8.8.8.8 plus 32, gateway ISP1, which is 101.168.101, and that one. Okay, distance, no problem. Here we have by default we have scope 30 and target scope 30 and target scope 10. We need to remember the scope 30. We will use it in the to create the other route. Okay, okay. The second one is 8.8.8, and to go to that we need to use the ISP2. ISP2 needs okay, ISP2. Let's go check ping. Okay, here also we need to check gateway ping. Okay, the third public DNS, I'm going to use 1.1.1.1.32. The gateway, I am going to use the third one, the third ISP, and by default it's the scope is 30. Okay, and the last one is, let's use 9999. It will go through the 4 ISPs, check gateway, and then apply. Okay, so now we are going to create the routine for our traffic. So the first, we will route everything toward ISP1, and then distance is 1, then the scope and the target scope. Remember, in MikroTik, the target scope means that anything in the routing table that has a scope, for example, of 30 or 10 or smaller, will be accepted. By default, MikroTik cannot use this link, cannot use 8.8, because it's not directly connected. So with the scope and the target scope, so here you tell, remember that here to go to the 8, the scope is 30. So when we come, I think it's okay, when we come here and we see that to go to 8, the distance 1, the scope and the target scope. When we see the target scope is 30, it means that anything in the routing table that have scope of 30 and smaller, it will be accepted. And the ISP via ISP1. So we are going to forward and to send traffic that are marked as ISP1. So which they are like connection 1. So they are going to be sent through ISP1. Okay, apply, copy. Now we are using ISP as a backup, as the second backup, which is 4.4. as the distance, administrative distance, it will be used as the second backup. Apply, copy. We are going to use the third ISP as the third backup for the, and apply, copy, and we are going to use the 4 ISP as the fourth backup. Apply, okay. Now we are going to send all the traffic that are marked as connection 2 via ISP2. So 8.8, that's 4.4. Okay, distance 1, scope and target scope, we say 13, routing table via ISP2. Okay, apply, copy. We are going to use 1 as the second backup, in case the ISP2 fell down. We'll send it through the second backup or the third ISP. Apply, copy. We are going to use 9.9 as the third backup in case of failover, and then apply. And the last one is 8.8, sorry, 8.8 as the fourth backup. Okay, apply, okay. So yes, you can see here that the traffic that's marked as connection 1 and they are going to go via ISP1 is active, because and it will use 8.8.8, which is ISP1, and then the second ISP2 is active in the second ISPs. Or the other, they are like backup in case of we will be using in case of failover. Okay, now let's do the same for the connection 3. Okay, it will be, yes, ISP3 is 1.1.1. Target scope is 30. ISP is via ISP3. Apply, copy. 9.9 will be used as the second backup for the packet that are marked as connection 3. Apply, and then 8.8 will be the third. Apply, copy, and 8.4.4 will be used as the fourth backup for the ISP3 connection. Apply. Okay. And also you can see that here that distance 1, so it is active. It is active for the ISP3 connection. And the last one is to forward all the packets that are marked as connection 4 through the ISP4. The target scope is 13, and the main routine is ISP4. Apply, copy, make this as the second backup. First I did the second backup, apply, copy, then the second ISP as the third backup for the ISP4 connection. Apply, and then 1.1.1 as the fourth backup for connection, for ISP4 connection. Okay, apply. Okay. Yes, it is. See that it is active here. So, and now we can for the other traffic that are not marked, we can create a routine table to send them all to the ISP1 first, and then make the other as the backup. So we are going to send everything to the 8.8, which is going through ISP1, and distance is 1. Keep it the main, so we will send everything that's the traffic that are not marked. And so okay. Right, it is okay. I don't know why it is disabled. Yeah, okay. I don't know why it's shown disabled. Okay, maybe it's just an issue. It's just an issue of virtual lab. Sometimes it's happen. Let's create second one is 8. Mark it as 2. Oh yes, sorry, we need to target scope, we need to change it also to okay. Yes, we need to but we change it the first one. Okay, 8.8 and apply, copy. Okay, 8.8 4.4, add the second, apply, copy, as the third, backup, apply, copy, and the last one is 9 as the fourth. Okay, so we forget the target scope, that's why it was shown as disabled. Apply, okay. So yeah, now it seems everything seems good. So let's go and test IP firewall connection. Now we see some connection, they are coming because the ping that the IC ping. So what we are going to do now is that we have like 4 pieces here. Let's connect them to the MikroTik and try to reach the internet, and we will see that each connection take different ISPs and different paths. Okay, have here. Okay, let's use this one. Okay, let's connect it to the network, the ICP, apply. Okay, let's go to, I don't know, Facebook. Okay, it is Facebook. You can see here that different connection is because we have both addresses, so different connection have been created. ISP, you will find to go to this address from this address, so that it was like markets at ISP2. Here is a different one, so it is markets at ISP4, so it's per connection classifier. Okay, so let's for example go to YouTube. Okay, let's go to the second PC, apply. Okay, and Google. So okay, this one is not working. Why? Okay, Instagram for example. So yes, the connection is created, so we can go now. The first IP was 251 and it's ISP3, then it's used ISP1. So even the same the same PC with the same host will, depending on this because we choose like the source and the public. Each time the source and the public and the destination address is different, so we can he can mark it as a new connection and take another ISP. So so with this way you can like mark and dispatch traffic between the 4 ISPs, and we can use them in the best way. So yes, this is the second second IP, the second host, so 252, and yes, it is marked as connection 3. We have probably this is Instagram, and then Google. This is marked as ISP4. So yes, so we can see that the MikroTik is load balance the traffic between the 4 ISPs. So we can add like another test. You can control panel, network, and then configure the ISP because I have the ISP configured in the MikroTik. Apply, OK, and so we can go to the Yahoo. Yes, Yahoo. Yes, it's open. So I think it will be, yeah, it will be 253, and then yes, 253. Yes, maybe this is Yahoo or something. So yes, different connection. Okay, so and if we go to now to the Mangle, we will see that the traffic is marked in all interfaces, and it's going through the all interfaces equally. So this is how, so there is no need to go and do the force is the same. So you can go to control panel and then to network, so configure the CPS and then apply. Okay, and this will, if we, I don't know, it is Google. Yeah, it's working also. Yeah, TTY. Okay. So if you go to the connection here, I think it will be for, I think it is the for the 254, I think. So you can see that it's new ISP, the new connection is created. So this is how we can load balance between 4 ISPs in the using the MikroTik router. So if you go, you can find that yes, indeed, all the interfaces that are working, and the traffic are marked correctly, and it's working just fine. So this is how you can configure the load balancing in MikroTik router version 7 using recursive router recursive using public DNS. Thank you for watching.